Hi. So yesterday we discussed more about the Stream API introduction. What is a Stream API and we are calling it as a stream, or why they given name as a stream, and what is going to happen as part of the Stream API, especially when we are working with collection objects. So we started understanding about it. And before that, so we completed all predefined functional interfaces, especially the four like predicate, consumer, supplier, and function, right? And after that, we started discussion Stream API, and we understood as part of Stream API. So what is going to happen on your overview? We try to understand. So that means whenever we have a collection of objects or a group of values, what we are going to do is to do any operations. Operations is nothing but like if you want to make any conditions, applying conditions and filtering the data, or if you want to convert from one data type to another data type, like mapping from one object to another object. So, or you want to filter, you want to get the data from one format to another format, or you want to make sure collect the data between one property to another property. So these are all requirements, or these are all operations we can do via Stream API nowadays. So that means the collection object, first what we will do is we will convert that collection object into stream object. So that means in this case, the source, the original data source object is not at all disturbed while we are doing the operations. That means the operations what we are doing via Stream API is never ever done on the directly source. It is always done on the stream object, which is created from the real collection data source object. So that is what we understood here. So that means it's a stream now. So this stream contains all these collection values. And after that, what we will do, we will perform the operations. On this stream object, we will perform the operations. So here again, we have two types of operations. That is what we have to discuss today. One is intermediate and second one is terminal operations. So Stream API divided operations into two categories. One is terminal and second one is intermediate. So what is that intermediate? What is the terminal operations? We have to understand, and we have to see couple of methods also as part of today's session. So if you see this example yesterday, what we did here, it is we taken first list of objects, and from that list we created the stream object. And then once stream object got created, based on our requirement, what we did, we applied a method on this stream. So if you see here, so this one. So this is what stream object. Whatever the stream created here, that is the stream object we are using. And we are calling a method called as filter method. We are calling a method called as filter method. So, and we are passing a predicate. Why filter method? Taking method argument of predicate. So filter method always taking predicate argument. So that means we have to provide always predicate implementation. So based on the condition point of view, whatever the predicate we written, so that predicate I passed here it is. So filter method is from the Stream API. So now I passed the predicate. So again what you got? Again you got one more string. Again we got one more string. So that means what's happened from this main stream, from this master stream, once the filter is happened based on this condition, you got one more stream. So the result stream, not actual result. So again you got stream object only. So that means what happened again? Out of this 10 employee objects, whoever met this condition like greater than 50,000, for example, assume five employees are there. All those five objects again you got as a stream object. So that means again this stream object contains how many employee objects right now? 5. So it is a stream. You can't use stream again as a direct result. So you have to convert that stream into the real result. That means the real into real Java objects point of view. So that means again to do that we need always a terminal method. We need always a terminal method. So that means whenever we are working as part of the Stream API, especially, so if you see this example, what we taken yesterday only, so what we did here, this is the steps we followed, right? So we created stream, and then we created predicate to pass to the filter method, and that means again you got substream from the main stream, And again from that substream, the resulted stream you are calling a method called as toList. I mean, we have a lot of methods of terminal methods. So in this case, we are calling terminal method, terminal methods. So filter methods point of view, we used to call it as sorry, intermediate methods will be called as intermediate operation. Terminal methods will be called as terminal operations. So from this stream, again, what I did, I called a terminal method. So the moment I call the terminal method, what's happening here it is the entire stream, this entire stream, whatever the 5 objects it contains, right? So it is converted into an array list. So that means finally you got an array list of 5 objects, 5 employee objects. The moment you started it is 10 objects. The result you got 5 objects as a separate array list, as a separate list. So that means you performed the condition greater than 50,000 and you got the result of employees as a list again, as a list again. But in between that, what we did, we used intermediate operation, terminal operation. So if you see the above segregation of lines, if I am writing into one line, so that will come like this. All employees, the main source object, 10 employees. Okay. And then from that, what I did, I called stream. So that means converted to stream. And after that, I called filter method. And after that, I called toList method. Right. So that means here, this is the source object. Right. From that, what you did, we created stream. We created stream. And after that, what we did, we called intermediate operation. Intermediate operation. So filter is a intermediate operation. So the moment you call intermediate operation, what you will get result again? Again, one more stream you will get result stream. We will call it as result stream. Result as a stream. Simply I can say like result as a stream. So here the moment filter is happened with respect to this predicate implementation. So so assume here I said right 10 employee objects. 10 objects. Now, after this condition, after this predicate implementation, as a result, assume you got 5 objects, 5 objects, 5 employee objects. So that means it's a result. So now these 5 employee objects are having salary greater than 50,000. So at this line level, you got one more stream, and that stream contains 5 objects, 5 employee objects who are having salary greater than 50,000. So now that is what my requirement. I want all employees who is having salary greater than 50,000. So, but it is a stream. You got the result, but it is a stream. That means what happened in this from this requirement point of view? If you taken this solution again, yeah. So if you taken this solution, okay. So this is the line we return to get final result, right? So in this case, so if you take in the first one, 10 objects. So it's a main source object, the actual collection object, all employees, right? So from that, what we did, we called a method called a stream method so that you created a stream objects. Now the stream contains how many objects? 10 objects. So it's a main stream. No. So you created from the actual collection object, you created a stream, right? And from that stream, you called method based on the requirement point of view. We called a method called as filter, and we provided some predicate here, nothing but condition point of view. And what happened out of these 10 objects, all the employee objects got filtered based on the salary criteria. And assume you got five objects who are having salary greater than 50,000. Now, those five objects immediately you're not getting as a list. So it's not returning as a list. It's not returning as a list. So that means it is returning again what? Again a stream only. Again a stream only. So that means what you got here in this case is it is the master stream. So it is the input you given input source, and then from that what we did, we created stream. So you created mainstream. So it is a mainstream. That means the first time what we created stream from the input source. And on top of that, what we did, we called an operation. We called one more operation. So what operation on a stream you are going to call first time, what operation to achieve this some, okay, to see, we can call intermediate operations, we can call terminal operation. So usually so here you have to understand couple of points. Please remember this. For example, I called intermediate operation one. So what, for example, filter method. So filter method is an intermediate operation. So the moment you called filter method, what is the result you got? So again, stream only you got. So that means again a stream only. The result from this intermediate operation, what it is? Stream. Result. So you got again stream only. One more stream. But the result of the, so as a result, what you got? Stream only. But we can't utilize stream as a result. The real result, like we can utilize that for other operations point of view, we can't use the stream. So the moment you can create a stream, you can utilize this stream, but once you are closing that pipeline, so I'll come back that point. What will happen? So now what you have to do, in case if you have any further conditions, in case if you have any further intermediate operations or further requirement, you can apply one more intermediate operation also. So that means we can apply, in case if you want, we can apply one more intermediate operation. Intermediate operation. In case of if you have requirement, instead of terminating, instead of getting result directly from this, in case if you have one more intermediate operations, you can perform. So that means you can call n number of intermediate operations or n number of intermediate operations in a sequence based on the requirement point of view. In a sequence, we can call any number of intermediate operations. But but at the end, always a stream should contain, must and should, one terminal operation. One terminal operation. So one terminal operation. One terminal operation. So here the moment, see, understand the point. The moment you are calling intermediate operations, what you will get result here it is, you will get again result as a stream only. You will get again one more result stream only. So we will get again one more stream only. So result as a stream only. So that means all I'll make a point from here. We can make a point from here. It is what it is. What is the point we can make? Some from the summary here it is. All intermediate operations or methods, okay, returns always a stream only. Always returns a stream only. Always a stream only. Okay. All terminal operations are methods. All terminal operations are methods. Returns a result from the string. So nothing but what we can understand from this point, nothing but a stream. Okay, when we are calling, so when we call terminal method, that means you are terminating the operation, you are terminating the pipeline like that. So that's why they given terminal terminology. So when we call terminal method, immediately in stream pipeline, all intermediate operations are executed, and and final stream and result of and all intermediate operations are executed, and result of all intermediate operations is convert. So generally what is the result of all intermediate operations is stream, right? So nothing but I can call it as a final stream. So it's a result is always a stream, right? So it's always stream is converted into the real Java objects into some based on the point. If it is a to list, then you'll get array list of objects, something else count integer value. So into a converted into the real result. So that means what is the point here? It is you have to understand here. It is again from this. Okay, let's come back here. So now in this case, this is the terminal operator. So how many intermediate operations we can call in a stream pipeline? So now see, this overall will be called as stream pipeline, guys. So the moment you call terminal operation, what you will get is you will get a real result. So result means it might be list of objects, it might be a integer value, it might be a string value, whatever it is, but not a string. So that means what is the point? This is this overall I can call it as a stream pipeline. You're piping the pipeline. What is the meaning of pipeline? Pipeline. So it will be called as stream pipeline. In interviews, they will ask you like, so what is a stream pipeline? So the mean nothing but stream pipeline is nothing but whenever we have a source collection object or data source object, the moment you converted stream we converted into stream by calling stream method. And if you are calling any intermediate methods as well as terminal operation, and whenever you got the result, right, this entire sequence of operations or actions, okay, will be called as a stream pipeline. You made a pipeline here it is. So that means what you are trying to say here it is step number one. So in this case, what we are trying to say here, step number one is taking the input and converting to stream. Step number two, intermediate operation. Okay, then again what you got, result stream only. And again step number three, you are calling one more operation. Again you got result stream only. Again what you are doing, one more intermediate operation, or else if you have a terminal operation, you can call the terminal. Finally got the result. So this entire sequence of actions or whatever you just made, your connectivity between one thing to another thing is called as pipeline, stream pipeline. Stream pipeline. Now I'll write one more point here it is. A stream pipeline should have always only one terminal operation mandatory. So what it is saying, only one terminal operation. You will not allow. So that means stream pipeline is not should not be allowed. Okay, stream pipeline will not be allowed more than one terminal method. More than one terminal method, but allowed more intermediate methods. More intermediate methods. And I'll write one more point. In stream pipeline, in stream pipeline, first we have to write, we have to use intermediate operations, and at last, that means while terminating that, and at last to terminate stream pipeline and converting result stream into result. After all intermediate operations, you will get a final result stream. So convert it into result. Okay, so at last, that means to terminate the stream pipeline and converting the resulted stream into the real result or actual result, whatever it is, we have to use terminal method. Okay, so that means here lot of points are there. So without terminal operation, there will not be stream pipeline. Okay, and without terminal operation, you will not get the real result. And you can utilize only one terminal operation always. But you can write n number of intermediate operations. And terminal method only always returns the stream into the real Java objects or real Java data. But okay, intermediate operations always returns only streams only. Only stream only. Only streams only. So, but you can write any number of intermediate operations, but not terminal is only one. And every time stream pipeline is contains mandatorily one terminal operation. So these are all rules you have to remember while you are implementing the stream API. Now, if you come back to the diagram here again, so this is called as stream API. Sorry, stream pipeline. So n number of intermediate operations. If you observe here, n number of intermediate operations. If you see, so these are all intermediate operations. But terminal operation point of view, only one you have to use. And when you have to use terminal operation, guys, the moment you are terminating the stream pipeline, nothing but you are converting into result, then only you have to call the terminal. So that means based on that, can I call, for example, if it is a stream, intermediate operation, terminal operation, and intermediate operation? No, it's not possible. So that means stream, from that you call intermediate operation. So intermediate operation, and then again you call terminal operation. And then again intermediate operation. No, this combination is not available, not allowed. So why that means why it's not allowed in this case is, yeah, so in this case it intermediate, it's a wrong, it's not allowed. Why? The problem here it is, the moment you give an terminal operation, it will convert immediately that whatever the stream you are having at this level, whatever the stream you are having at this level, it will convert directly into a Java object and it is terminating the process. So that means you can't make again one more terminal operation, like that. Okay, so that is how you have to remember while you are using the operation. Now next point is, so how to remember or how to recognize which method is a terminal or intermediate operation. So how can we remember or how can we recognize at least, so which is a terminal, which is a intermediate operation point of view. So it's very simple, right? What is the rule I said? Intermediate methods always return string. Terminal methods always returns respective results, like sometimes list of object, integer value, string value, like that. A non-stream object. Simply I can select non-stream. So if you go to the Stream API one more time. So if you open the Stream API, so if you see these methods, now from this, what I can say, Boolean return type I'm getting. So the moment Boolean means it's a terminal. Okay. And if you see here count, long value. So it's a terminal. Distinct, you got what? String. So that means intermediate. Long is a terminal operation. So why you are getting some long value, a real Java object, Boolean value, terminal operation, Boolean value, terminal operation. And yeah, so if you see here filter, this is what we are understanding. Filter returning stream. That means what I am saying, like this is an intermediate operation, right? Optional. So it's a again what? Terminal operation. It's not a stream simply. So what is an optional? I'll teach you after stream, guys. I forgot to take it up, but anyway, I'll teach you. It's very simple point of view. I forgot to teach it. Okay, so we will see that what is an optional and all. I'll. Okay. It's a very small class only. I'll teach it. Okay, stream point of view. You got that means again intermediate operation. So that means the methods from the stream API, whatever you are seeing here, which are returning a real result. See into stream. That means can I consider it as a intermediate or terminal means it's an intermediate only. You got stream again. So like that. Okay, it's a terminal operations point of view. So terminal operations. So min, no, max and boolean. It's all terminal operations, right? So like that, you have to recognize which is a terminal, which is a intermediate operation. Simply stream, if it is returning stream means it is a intermediate operation. And stream pipeline must and should have always a terminal method to get into a result, to convert that stream into a result. You should have it. Okay, so to execute all sequence of aligned intermediate operations also, you have to utilize always a terminal method. So simple, you need always a terminal. Then finally what will happen? First, this one will be executed and you will get the result. And that result will be again executed by another operation. And again, you will get one more result. And again, on top of that result, you can call if you have any intermediate method, okay. Or else if you are calling terminal operation, then this last stream will be converted into respective result. So the result is happening from this tree. So it's a simple common sense topic only. You are making multiple intermediate operations, filtering, applying something. At the end, whenever you want result, then you are simply calling the terminal method, like, and you are converting that stream into result. So it will take last stream based on the last intermediate operation, and then finally it will make into result. Because terminal method should be allowed always after the intermediate methods, after all intermediate methods. Okay, so let's see practical examples with respect to this now. Now, if you go here, so what I said, created stream called intermediate operation, and toList is a terminal operation. toList is a terminal operation. So that's why I am calling it as a stream pipeline. Why? Source, mainstream, intermediate operation, terminal operation. The moment I call terminal operation, what I got? I got result of employees, nothing but list of employees. Nothing but list of employees. So what I got? All list of employees. Nothing but result I got. Finally, what I got? A list of employees I got. So now definitely it will have out of 10 objects, 5 to 6 objects only who are having salary greater than 50,000. So here it is a tunnel. So now this overall will be called as stream pipeline. Source, stream, intermediate operation as well as terminal operation. So this is called as stream pipeline and you are calling at the end terminal operation. So terminal operation, see terminal operation is method. What is the return type? Array list, a list of objects. That means it's a terminal. Filter method, why I am saying like a intermediate operation, the return type is stream. Now let's take one more example. What is that example is? Get all employees names whose mm, age is greater than 30. So that means from the all employees list. So I want to get whose name, okay, whose age is greater than 30. All employee objects whose age is greater than is 30. What I want to get names. What I want to get names. Or I can print get all employee names as a list. For example, I'll take like this. So I want all employee names as a list whose age is greater than 30. Understand the point? Only employee names I want. In earlier case, what you got whose salary is greater than 50,000, all employee objects. You got only employee objects, but this time I want names like only, for example, 30, right? 2, 3, 5, 7, 8. Okay, if you are including 10 also, 10, 30, I mean 30 also 10 then. So that means I want only names, list of names. So what you have to do? What is the first requirement you have to take in this case? A list whose age is greater than 30. So that means from this requirement, what you understand, first you have to filter whose age is 30, greater than 30, right? Greater than 30. Then what will happen? You will get a result. You will get a sub result. You will get a sub result. And from that sub result, what is the sub result you will get? You are operating on the employee objects. Source is what in this case? In this case, the main source is list of employee objects. List of employee object. List of employee objects. So that means the sub result what you will get again. So sub result employee objects only. In case if you are terminating it, again what you will get all employee objects. But I don't want employee objects. Whose age is greater than 30, you will get employee objects. But I want to make sure from that employee objects again, I want to get only employee names. Only employee names. I want to take again one by one employee. For example, assume you got here 5 employee objects. So now from those 5 objects, I want to get only employee names. So then finally that employee names I have to convert it to string. I want to get it as a list. List of names. This is what my requirement. So this one line, if I decoded or segregated like list from the list of all employee objects, filter whose age is greater than 30. Okay. And finally make sure I want only names as a list. So let's take this requirement. So what is our source in this case again? All employees. Sorry, this one. All employees, right? So from here you are getting all employees. You are getting all employees, right? So let's take this all employees again. Come back here. Okay, source. And what I said, stream object. So you converted that into stream. Okay, fine. So you can write like this, no problem. So it's a source. And then you convert it to stream. And then dot. So what is the next requirement it is saying? What is the criteria? Whose age is greater than 30? So that means whenever it is a conditional requirement, whenever it is a condition requirement, whenever it is a condition requirement, we have a method called as filter method. And filter method is taking what argument, guys? If you observe here, predicate. Predicate of which type? Employee type. Predicate of employee type. So predicate means you have to provide a lambda expression which is associated to the predicate functional interface. So that means what is the lambda expression I am providing here? It is, see, this stream contains what objects, what type of objects, employee objects. Data type is what? The stream data type. See, this is how we have to write the stream operations, guys. We should not write like this. We can write like this, like converting stream in one line, and then again from that stream you're writing predicate separately, and then you're using that predicate filter level. Okay, so you may write it like this, not a big deal, but whenever you're doing basic small operations, instead of segregating into one, two, three lines, okay, so you have to write always in a proper way. So we have to write always this approach only. So a sequence of actions, just you need to build it as a pipeline point of view. So what filter is saying, all employee objects one by one point of view. I want to check employee dot get salary. Sorry, not salary this time. Age, right? Get age greater than or equal to 30. So including 30 also. So whose age is greater than 30, filter all the employees. So what is the meaning of it is, filter all employee objects. Filter all employee objects whose age is greater than or equal to 30. Greater than or equal to 30. So that's what. Now, what is the result again for this filter? Filter is an intermediate operation. What is this? It is an intermediate operation. How I am saying like it is an intermediate operation. So if you see the result type of filter, what it is saying? Stream of type. Type means in this case we are using employee objects. So that's why employee. So that means what? It is a stream. It is returning a stream again. So to convert that stream into a result, a real result, you need always a terminal method. But actually, if I'm terminating here, for example, by using the toList method, that means it will convert list of what? If you observe here, employee objects. Why? In this case, the filter method, whenever you called, you got one more stream only, but stream with what objects? Employee type objects. Stream with employee objects. So from the all employees, you created the stream. We created the stream, and then so that means it contains all employee objects. And you just only made filter. At the end, you got stream. But again, what that stream contains? All employee object only. So that means the result in this case again is what? So in this case, the result is again stream of employee objects. One best example will lead you all the I mean it will avoid all the confusion, guys. That's why I'm taking this much carefully, one small one best example. So if you got the clarity what's happening at a what method level and how you are using the intermediate and terminal operations, then you can build a big stream pipeline. You can build a big stream pipeline automatically. So if you have a common sense, I mean what's happening at each and every method level. So stream of employee objects. If I converted this into toList, what will happen? Okay, it's a terminal operation. It's a terminal operation. So what this toolist method is say doing, from this stream of employee objects, okay, from the above stream, or from the above latest stream, okay, from the above latest stream, what it is doing, taking all employee objects and converted to converted to list of objects, the real list of objects. That's what it is doing. But my requirement is what? I don't want all list employee objects again. I don't want employee objects. I want only names as a list. So that means you can expect what is the output in this case, the result point of view. What is the result you are expecting in this case is list of string type. I want string. That means what? Like I want all the names like Dilip, Suresh, Naresh, like that. So that means what is the result? List. But in this case, what's happening? If you observe the list you got. So that means you will get the moment here what? List of employee objects. List of employee. See here. You got all employees once you are calling the terminal operation. List of employee, but I want only names. So until this, okay, I got all employees whose age is greater than 30. But now what I have to do in the next step? Yeah, what you have to do here as a next step point of view, convert above result to stream. Okay, or I can do like that instead of convert. Okay, so I'll write like this. From the above result stream of filter method. So whatever filter method is executed once you got stream, right? So from that result stream of filter method, what you have to do is map. So what you got source, in this case source is employee type. Source is employee, but I want what from that name only a name. I want to pick up only name from that employee object. So that means what you have to do, just get employee, get employees names from each employee object of string, from the string, from the string. So what I'm trying to say here it is, okay, so what you got, all 5 employee objects available in the stream. Okay, the result from that what you have to do is, from this stream, the stream contains employee object, right? So what I'm saying, from that employee objects, pick up only name, only name. So for that what you have to do is, so that means what you are doing ultimately here, the type you are having employee, and from that you want string, data. So from employee object you are getting string data. So input is employee object, output is string data from for every employee point of view, right? So like that, for example, if you take an main source, filter operation, and then you got sub source. So it's a filter. You call filter here. Filter with that condition, with that predicate greater than 30. Age. So based on the age point of view. So then what you got, all employee objects. For example, I'll take one of the employee object like Dilip. Age is okay. Let's take this one 7:45. This data. One of the example. Okay. So in this case, what you observe, this is the resulted stream level. You got this employee object. Now from this, I want to pick up. So this is what employee object. It's a one of the employee objects in the string. It's a string. Like that, you have all employee, all other employee objects also. One another employee objects. Okay. So then from this, I want to pick up only name. I want to pick up only name. So I don't want entire employee object. If you want entire employee objects as a list, just directly list, to list, terminal, done. Terminate the process. Terminate the process. But I don't want. I want again from this stream of employee objects, I want to get only names. So that means from the first employee object, I want to get this 7. Similarly, comma, from the second employee object point of view, maybe 10, like that. And I want third employee object point of view whose age is greater than 8. So that means 8. Like that, I want only all employee names this time. So that means if you are thinking in this perspective, source is what? I mean, employee. But you are converting into From that employee, you are picking only name, that means string. So from employee object to string, you are doing the what? Mapping. So it will be called as mapping. So what you are doing? Mapping. From one data type to another data type, you are doing that from employee to. So here assume this stream is having 5 objects. So here it is having 10 objects, array list with 10 objects. After filter assume you got 5. Now can you tell me in this case how many objects you will get? So is there any possibility? See here based on the condition, count will vary. So it might be 10 to sometimes 0 also will happen. But when you are doing the mapping, in this case source, in this red line highlighted point of view, this became as a source. Now this latest stream became as a source stream. And the moment you are doing the mapping, for example, if it is having 5 objects, how many names you will get? Again 5 names only. Simple. From each and every employee object, you are picking the name. So that's all. So 5 names you are going to get. All employee objects are having names. So that means you will get the 5 names as a result. So now what you got? This names again as a stream only. So these names again you will get stream. Again you got as a stream object. So finally you got names only, but as a stream object. As a stream object. So to convert this stream object to the real list of employee objects, then you have to call terminal operation. So terminal operation. So now you can call toList method, then it will convert this stream object into a list object. What is the data type in this case? String, right? So stream with string this time. So then it will convert list of string. It will convert list of string. So that means the moment you are calling terminal method, in this case list, it is what data type objects available in that latest stream, that list it will create automatically. If you are calling toList here, by the time what objects it contains employee, that's a list of employee. So now what you have to do, second operation, terminal operation 1, filter we did already based on the requirement point. Second terminal operation, what I have to do? Mapping. Second terminal operation, what I have to do? Mapping I have to do. So from employee object to string data. So let's come back here. So what I am doing? Filter and followed by, you got dot. Dot means you are making a pipeline and you are calling from that. Dot map. So if you observe here again, map is a predefined method from the stream API. Map. And what map was saying? It is taking argument of what, guys? Function. Function, functional interface. You know that, right? What function will do? In our previous sessions, we discussed function. So what is the importance of function? It will take one argument, one type, and it will return any type. So that means in this case, accept method, right? We have what? Function level accept method. We discussed, right? Accept method, all these things. So not accept, apply, sorry, apply. So in this case, apply point of view, what you're having input is one type, return type is another type, any type. So that means based on this, if you taken this function interface, that means map method is taking in this case. So what method you are using, guys? This time map. So map is taking internally function functional interface. So with respect to function functional interface, what is that? Apply method. So in this case, what you are applying, you are passing employee, and from that you are returning string. Now let's implement a lambda expression based on the function interface point of view. So map, okay, fine. Directly I'm writing the lambda expression. Now in this case, how to understand? The previous intermediate operation resulting what? Stream only. What type of objects? Internally it contains the result stream employee. So that means here also, when you are doing the map operation, you will get employee object. So I'm taking, again in this case, some reference variable. You can take employee, whatever it is, EMP also, whatever it is, employee ABC XYZ, you can take anything. I'm taking E. hyphen, sorry, implies what? E dot get name. E dot get name. So that means what happened, what you are trying to say here it is. Okay, let's do one thing. Sorry, I already have it. Okay, here I'll remove it. Okay, let's remove it first, then you'll get the clarity. Okay, so yeah, so now understand here. What happened in this case? E is a what type? Employee type. And from that, E, you are implementing a lambda expression like E dot get name. So that means you are retrieving employee name. So what is the return value in this case? Name, nothing but string. So that means ultimately this line is executed. What you got? One more stream with only all employee names. All employee names. All employee names. So this time stream with only employee names. What data type? Name data type is what? String, right? So that means it's nothing but string. So you got a one more stream object with string data type. So filter point of view, stream with employee objects. Map point of view, you are mapping employee object. Okay, you are from every employee object, you are reading the name, and finally what is happening? All internally, you got one more stream object with employee names. That thing but string. The result of map, see, observe here what it will return. Stream R. In this case, in our case, what is the R return means? String data type. So that means we got stream of string. So now ultimately what you have guys at this line number 58 level, stream with string values. Stream with string values. Now I'm calling a method called as toList method. Now I'm calling a method is toList method. So that means the moment you call the toList method, what it will do, what is the latest stream with data type string? So it will convert all the stream employee names as a array list. So let's see here. I'm writing at the list string names equal to. See, the operation is completed. So now in this case, how many intermediate operations we called, how many terminal operations we called means you can observe. Sometimes editors are bad. Okay, so anyway, you can observe from here. Yeah, if you observe here, intermediate operation 1, intermediate operation 2, and finally total 3 operations, 2 intermediate operations, 1 terminal operation. 1 terminal. For example, if you don't have the terminal operation, what will happen guys? In this case, you will get the result, but what? Again a stream only. So see here, stream. Again you got a stream, but you can't utilize the stream for other operations. You can't utilize stream for other operations like passing this again this data to some database level, or you want to pass this stream. I mean, you can't do that like that. So you can use it, but ultimately at the end it's better to get always a list only. To convert a stream into a real Java object or real Java data point of view, you have to use terminal operation. So that's why I made two list. Then again it is converted to list because that method converting that stream into list, to list method in this case especially. So this is one of the example only. You have two array also. So that means what it will do? Two array. It will convert into array of names. Like that. Okay. So it will take care of that. Is two string point of view. You can do that. Array point of view. Okay. So this is how you are going to utilize intermediate and terminal operations based on the requirement. In entire point of view, mostly every day You most of the times you will use filter method and map method, guys. In most of the scenarios, we will use map and filter method. Map and filter method. Okay. So now let's take one more requirement. Okay, let's take one more class instead of writing everything in one point. So new class. Okay. Okay. So let's take all employee objects list of import the class and I'll take array list only anyway. So then I'll take employee all employees equal to stream API demo dot get all employees. So from there I'm getting all employees objects again. So from here I am getting all this employee data once again here. Okay. So here I have all employees. Now let's take one more requirement. So then we can form simply one by one point of view. What I can take in this case is okay. So get the count, get the count, get the count of all, get the count of employees. You can add more properties, guys. Then you will get lot of interest. You can add gender. Okay. Even I can add also. Let's do one thing. But I have to prepare data once again. Okay, let's do one thing. I'll take ChatGPT. Hmm. Instead of I'm preparing here, preparing data is biggest challenge. I mean, just like this, you or we all know this. Yeah, preparing this data is biggest challenge. That's why I'm taking this one. Okay, so what I will do, I'll take this properties. I'll write So generate. So that I can use this class for tomorrow class. Tomorrow also I can use this data. Okay, so finally I'm done with data. Okay, let's see here. Okay, now you go out with all the employees which is having more information like the gender, all these things. Now get the count of female employees. Get the count of female employees. So how can you get it? So here you have list of employee objects and I want count. For example, if it is five female employees, two female employees, three or whatever it is. First of all, I have that property, gender property. Yeah, I have gender property, right? So yes. So if you see here, data point of view, you have, yeah, male, female, gender. So overall, how many female employees are there? I want that. So let's see here how to do that. If it is a regular programming approach, for loops, if conditions, you have to use all these things. For loops, if conditions, all these things. If you want to achieve this requirement, what you have to do, first you have to iterate this via for loop, and if you have to write a condition, if condition, and then okay, so you have to write all this story. If employee dot something like that, employee dot get gender, okay, equal to equals, ignore case, something like you will write like female. Then again you will create a new array list, like you will create a new array list, like list of again one more employee type, sorry count, sorry count you will take, like integer female employee count equal to initially 0. So then if it is matching, then what you will do, count female employee count plus plus, you will do that. So and then finally you will get the count. This is the old approach. That's what I said. Nowadays very rare case people are using for loops, especially see nobody, I mean I nobody is encouraging this kind of okay traditional programming, especially when you are using this stream APIs. I mean when we are utilizing, we have to utilize the stream API. So so see here, now I will get the result. See, finally at the end you will get the result. That's not the big deal. Okay, let's execute this program. What is invalid? Yeah, you got what? 5. You got what? 5. So that means in this case, ultimately what you got, five female employees are there. Yes, obviously. One, two, three, four, 5. So you got the count 5. But this is the traditional program. But if you are doing same thing with via Stream API, let's see how it is. So these many lines you written, right? But if you go with Stream API point of view, see. Okay, first, what source? What is the source? All employee list objects. Okay, fine. Dot stream dot now. So what you did from this step number 1, leave the filter first. Filter. Okay, you created the stream object. We created main stream. mainstream. And then from that, what is your first condition? Ignore it. Eclipse is giving the coding also. Okay. So what is your next count of female employees? So that means first of all, you have to identify female employees. From all employee objects, you have to identify the female employees. You have to filter only. So identifying means step number 2, what you have to do? Identify the female employees. Identify female employees. That is what you are doing. Identifying the female employees. To identify the female employees, what you have to do? You are utilizing the filter method. Filter is all about condition. So I'm taking employee whose gender is matching to the female. So that means now by the time this filter method is executed, what is our result, guys? In this case, you got, it's an intermediate operation. So intermediate operation means you will get the stream. But what is the stream you are having result of? What is the result you got in this case as a stream? All female employee objects. All female employee objects. So that means in this case, how many objects you got again? 5 objects, because we have 5 female employees. But what you got stream? See, in this case, by the time you created mainstream, 10 employee objects. But here you got 5 employee objects. Again, employee objects only. But it's all employee objects. But what I want, my requirement point of view, I want only count. I want just like count 5, 10, like that. I don't want all employee objects. So that means the required stream you got. Now you have to pick up this 5 value. So that means we have to terminate the stream pipeline. We have to terminate the operations, intermediate operations, and I have to convert this stream into a result. By terminating the stream pipeline, I have to get the result. Okay, so let's see here. That means you can see any previous methods, predefined methods available or not. See here. Dot, that dot means count. If you see here, what is this? This method is given by stream API only, long value. So that means it is giving count value. So that means this is the beginning, this is the ending. So here finally what it is returning, long female count, female employee count. Okay, already I have above, right? Yeah, female count, whatever it is. Now you got that. So let's print it. So you got 5 again. See how simple it is. Even if I am writing all this all this description, that's why you see very big. Otherwise, if you taken same thing again without the description, see here. If you're writing everything in one line, dot stream, converted to stream, and then filtering, even I can take simply e dot get gender, okay, equals ignore case female, whatever it is, and then count. So simply you're calling count. So sequence of action, sequence of operations, intermediate, and finally terminal operation. So you got long count. That's all. Female count. So within one line, you got all the solution. Like whatever you did in the traditional programming point of view, for loop, iterating, and then following if conditions and everything, you made everything via what? See, what are the topics involved in this case, guys? So in this case, if you observe stream concept, filter is taking what? Predicate. In earlier case, when I given map taking function. Now understand the importance of predefined functional interfaces and lambda expressions. That's why people are focusing or okay pressuring you more and more on the functional interfaces and lambda expression interview in interviews especially. in interviews especially. No, equals ignore is a method from the string class. Get gender is returning what string value. So this is a method. That means the value whatever comes from this. Sometimes what will happen if you are not using equal, if you are using only equals method, there is two methods. It will exactly match case. If you given female now, you will get 0. So 0. Why? Because if you observe the data, you given everything in the f in the capital and remaining in the lowercase, right? But now see here, if you given equals female, okay, you are not printed it. Let's print last one also. Then you will get 0. This time you will get 0. Why? You given exactly case. So you 0 you got. Why? You given equals means exactly it will match female word with all the females. So not matching, not matching 0. So you are using this method. It's a string class method, guys. It's not in from string class method. String. So go and explore the string class. That's what I said in earlier days itself. Please practice string class thoroughly. There are a lot of methods available. Equals, equals, ignore case, concat, substring, two array, two character array, like that. Lot of methods available. Please get the knowledge on the string class. This is the most used data type in entire Java programming language everywhere. Okay, so just now if I give an equals ignore case, that means I'm telling to the Java, ignore the case. If word is matching, then consider it. Now 5 we will get. Now it will just compare only word. It is ignoring the case. Now you will get the 5. So such scenarios you will use the ignore case. When you want exact match, then you have to use equals. Exact word character to character case also. Case is also has to be considered. Then you have to use equals. Like that string provided two methods. So it returning string, right? Get gender is what data type? String data type. So on that you are applying that. So like that. You are giving the condition. Okay, so this is how you are going to write down the things. Now let's take one more requirement very clearly, quickly. Let's complete now. Few other requirement point of view. What I will do is get all female employee or male employee names. Get all female employee names. So as a list only. For example, I want no, I don't want as a list. Print all employee. I'll this time my requirement is I want to print all employee, all female employee. Print all female, sorry, male employee names. So I want to print all male employee names. So from the list, from this all employees, you have to identify first what male employees. Then you have to print their names. So what you have to do here it is see. First of all, basic thing is stream dot filter. Why filter? You have to get the gender. Then only you can identify from the filter what you're doing. You want this time male employees. So it will give stream object identifier who are male. And then from that, what you want? You have a method called as for each method, guys, in this case. Okay, for each method. If you see here, what is this for each method? Void. So terminal operation. Terminal operation. So you can use for each. So what is the meaning of for each in this case saying is from the result of stream. For example, I assume you got to stream with 5 employee objects, right? 5 employee objects. Now what for each method will do in this case is it's a stream only again. On stream you are calling for each method. For each means it's nothing but for each loop. Looks like for each loop only. So they take a name from this one only. So what for each loop will do generally? It will take each and every employee object from all employees, right? Similarly, in this case, this for each method will pick up all employee object from this stream. From the latest stream, it will pick up all employee objects one by one and it will perform an action what you will do here. And observe the for each method argument. I forgot to show you that. See here, for each, what is the argument, guys? For each method of consumer. Consumer. So what is the nature of consumer generally? What is the nature of consumer? When we discussed about consumer, what is the nature I said? Void, accept, argument. So consumer point of view, consumer functional interface point of view, what we discussed, it will have a method called as accept. It will take input value, but it will not return anything. So that is how you have to write what a lambda expression now. So now in this case, employee is input. In my point of view now, employee is a input, and from that employee, I'm just printing the data. So what I did, I'm taking employee and I'm printing that employee here. And I'm printing that employee here. So employee printing the employee. Printing the employee means just printing. System.out.println is just like printing. It will not return anything. It's a consumer now. Consumer point of view, input is there. You are doing some logic execution, but you are not returning any at the end you are not returning anything. So that means for each and every value will be printed from this. And what I want to print names only. If you are printing like this, what will happen? See here, it will print all employee information. So all employee information, but I don't want it, right? I don't want all these things. So then you can do one thing here directly from here, get a name. Now print it. All employee female, sorry, all male employee names you got it. See, now you are involved with consumer also. So what you understood as of now, filter is all about internally using predicate. Map method internally using function, and for each is using consumer. So that's why I told you, the moment you don't have knowledge of predicate function consumer, it's waste of time to learn stream API. You can't understand, even though if you are understanding, it is a by hearting process. Okay. So now let's take one more requirement. Uh, yeah. So just you have so many other methods, small methods we have. We will discuss that later. What is the data I have here? Yeah, joining, year of joining also I have, right? What is the data I have? Year of joining 2018, 15, 20, 2010, 2014, 2015. Okay. So let's take like this. Get all employees information. Get all employees information who joined after 2015. After 2015. So after 15, that means including 16 onwards who joined. So if you taken like that, this person is counted 1 and 2, 3, 4, 5, 6. Total 6 employees are there. So now I want to get all these 6 employees information. I mean, as a result, finally, I would like to see those 6 employees information. And what I said, all employees information, all employee information who joined after 2015. How can I segregate it? So all employees dot stream, that is common, converting to stream. And from that dot, you can do filter. If you are doing filter, what will happen? Yeah, you can do filter also. So employee dot, yeah, filter also we can do. Then employee dot employee who's get joining year, get joining greater than or okay, greater than 2015. 15. Then what you will get, all employee objects. From that, if you made two list, you will get it. You will get it. So list of what employee you are getting, and employees equal to, like that I taken. Now print it. Even in the list also you have a method, for each method, guys, dot for each. So from this you have employee and you can print all employees information. For each is a method. So you have for each loops, and as well as you have a shortcut for each methods also nowadays in list interface, as well as stream API level also you have. So now this for each is from the list class, list interface. This for each from the stream API, like that. So print it. What you got? All employees. See who's joining is after 2015 only. 18, 20, 21, 27, 17, 20, 16, 20, 19. So like that. So you got all employees. See, this is what the filtering operations, I mean, you will do in real time applications. So next, the same solution, I think you can write in one way also. Another way. So see here, second solution, second way of solution, the above one only. All employees dot stream dot, I think we have something match. Yeah, all match, any match. Yeah, predicate point of view, any match. So any match means if any condition is matching, then it will return true. Okay, so it's just return true means it will just check, compare if anyone else is there with the joining year, something like that. If nobody is there, then it will return true or false. Yeah, this is the only one thing you can take, or any match, no. Distinct, no. Find any, find first is a different. Map we understood. Max, min. Okay, comparator and all I'll explain later. Parallel streaming I'll explain later. Sequential and parallel tomorrow I'll explain. What is a sequential and what is a parallel? I'll explain tomorrow. Collectors also I'll explain tomorrow. So what I can suggest you is you just practice all these examples, like whatever it is, getting count of female employees, getting count of male employees. So you can imagine, you can create lot of questions. For example, if I will give you the questions, try to get it. Get count of employees who joined before 2017. Get employees who is having more salary, highest salary. Salary, similarly, min salary. So these are all things. If you are not able to do, we will see tomorrow also. And min salary, all this. So we have to discuss as part of this is. I'll make a note, otherwise we'll get the confusion. Comparable comparator, I'll explain later. Yeah. So what I will explain is tomorrow collectors is the one of the thing, important thing. Collectors in stream API. So this is the one of the most important from this. This is the one thing I'll discuss tomorrow. Collectors point of view. And apart from collectors, if I have time, I'll take optional class for some time, and then I'll discuss stream API methods again. So there is no relation with optional class and stream API, but actually this topic has to be completed earlier so that then only you can understand these methods, like what methods. If you go to the API documentation, You can see here optional, right? Yeah, it's returning optional object, min max. So in such case, I can here also find any optional. So you have to know what is an optional. That's why first I'll take optional for 10-15 minutes, or it will take generally half an hour class also. But anyway, no problem. We will discuss and then we'll discuss rest of the methods in the stream API. But it's not 100% required to practice your stream API and all, because whatever things we did as of now, so far, if you are able to do these things on your own by practically, you are very good with stream API. Like especially you have to remember all these rules: stream pipeline, intermediate operations. See, we are everywhere intermediate operations and terminal operation. More than one intermediate operation, we can use it. Tomorrow I'll come back. We will see some complex requirement where it is involving minimum 2 3 intermediate operations in a single pipeline. So we will see that. Okay, so that's all for today, and let's connect on tomorrow with Stream API only, but we'll discuss other details also. Okay, so you're almost good, 50 to 60% Stream API, you're almost done. So the basic fundamental and the rules and regulations also we discussed, especially. So these rules you have to remember always. And interviews they will ask you what is the difference between intermediate and terminal operation. Then you have to tell all these things. If I'm calling intermediate operation, then it will return stream. If I'm calling terminal operation, it will convert stream into a real result like Java objects, like that. I can call only one terminal operation in the stream API, but we can call multiple intermediate operations on the stream pipeline. So like that, you have to tell all this explanation. Yes. Okay, so that's all for today. Let's connect on tomorrow with the stream API only. Rest of the things we will see. Collectors is the most important thing. We will see that one also. Okay, thanks guys. And if you are interested, okay, I told you already, just go through the YouTube channel. There I have already one Stream API session for 3 hours. Same thing only I discussed. But if it is my point here, it is if you are listening my side only, but if you are listening one more time, it may give you lot of other attention, other examples to you. So that you can cover with multiple. You can go with this Stream API. Where maybe okay, so this Stream API point of view also I discussed a lot of points. So sometimes what will happen, few points may be missed in the class, or sometimes few points missed in the this session, but I added in the class. So anything can happen. So that's why just go through this session also, and it is also having a lot of attention by a lot of students. I mean, it is appreciated actually, my Stream API content. So you can see the reviews and everything. So that means it's very good session. I made with very carefully. So just go with this session also, because see, the moment you are getting more response from the real time people means that much important nowadays it is in industry. Nowadays that is that much important in industry. Okay, so that's why just concentrate on the Stream API more and more, and internally it is involving functional interfaces, lambda expressions also. Go through that.